Morning, respected sir. I am Pujita Krishnan. My roll number is 21951A0477. I am pursuing my BTech third year from Institute of Aeronautical Engineering in Electronics and Communication Department from Section B. Today, I would like to take up the privilege in presenting my art TikTok presentation on the topic Advanced Spectrum Sharing in 5G Cognitive Heterogeneous Networks in the subject Digital Signal Processing. Let's get started with our presentation. So our topic is Advanced Spectrum Sharing in 5G Cognitive Heterogeneous Networks. Before getting to a presentation, I would really like to thank my department and everyone for giving me this great and wonderful opportunity to do this presentation, as it helped me in gaining a very good knowledge, and I had uh, got to know many new things about this topic, and it is a very interesting topic also. So thank you for giving me this opportunity, sir. So let's get started with our presentation. Introduction. Advanced spectrum sharing is crucial in 5G cognitive heterogeneous networks to efficiently utilize the available spectrum resources. So, a cognitive radios enable dynamic spectrum access, allowing for improved spectrum sharing among different network entities. Heterogeneous networks consist of different technologies and deployment scenarios and necessitating sophisticated spectrum sharing mechanisms. So this is about the introduction. Moving on to our next slide, we will know what is key challenges. The coexistence of multiple technologies in heterogeneous networks require intelligent spectrum management strategies. Spectrum fragmentation and scarcity pose challenges in ensuring equitable and efficient spectrum allocation. Interference mitigation is essential to maintain QoS and spectral efficiency in shared spectrum environments. Spectrum sharing techniques. The dynamic spectrum access, that is DSA, enables opportunistic spectrum usage based on real-time availability and quality metrics. Spectrum sensing techniques such as energy detection and cyclostationary feature detection facilitate spectrum sharing in cognitive networks. Cooperative spectrum sensing leverages collaboration among network nodes to improve detection, accuracy, and reliability. This is about spectrum sharing techniques. These are the techniques of spectrum sharing. Moving on to our next slide. What is cognitive radio networks? Cognitive radios can adapt their transmission parameters such as frequency power modulation to optimize spectrum utilization. As we see in this picture, the spectrum efficiency, which is in WLA LAN, TV, military, LTE, and GSM. These all are the radio spectrums. Spectrum database provides information about available frequencies and facilitate dynamic spectrum allocation in cognitive radio networks. The cognitive radio networks enable efficient spectrum sharing through spectrum sensing, decision making, and reconfiguration capabilities. So, moving on to our next slide. Machine learning in spectrum sharing. Machine learning algorithms such as reinforcement learning and deep learning can enhance spectrum sharing decisions in dynamic environments. By analyzing historical data and network conditions, machine learning models can predict optimal spectrum access strategies. As we see in this picture, reinforcement learning in machine learning. Input is the raw data. We give the raw data as input, and that gets agent and environment best action will be taking place. Selection of algorithm and reward state, everything takes place in this in order to get the correct output. So, adaptive learning mechanisms can enable cognitive networks to continuously improve their spectrum sharing policies based on feedback and performance metrics. Spectrum sharing protocols. IEEE 1900.7 standardizes spectrum sensing and sharing protocols for cognitive radio networks, promoting interoperability and coexistence. Dynamic spectrum access protocols such as spectrum etiquette and listen before talk (LBT) ensures fair and efficient spectrum sharing among the users. The multi-channel coordination protocols like Common Control Channel (CCC) and Dynamic Spectrum Management (DSM) enables the coordination spectrum access in heterogeneous networks. So this is about spectrum sharing protocols. What is interference management? Interference management is like interference coordination techniques such as interference alignment and cancellation mitigate co-channel interference in shade spectrum environment. Cognitive interference management algorithm dynamically uh, adjust transmit powers and frequencies to minimize the interference and enhance network performance. Coexistence mechanisms such as spectrum sensing and interference avoidance enable multiple networks to share spectrum without causing harmful interference. Moving on to our next slide, what is quality of service? QoS considerations. QoS aware spectrum sharing algorithms prioritize users' quality of experience by considering factors like latency, throughput, and reliability. Cognitive load balancing techniques distributes traffic among available spectrum bands to optimize resource utilization and enhance QoS. Cross-technology interference mitigation mechanisms ensure the QoS requirements are met across diverse network technologies in heterogeneous environments. As we see in this picture, the bandwidth with quality of service rules applied and the bandwidth with no quality of service rules applied. That is the difference between the both. So the general internet use and online gaming services, video streaming services like Netflix and Amazon and all will work like this with no quality of service, and with quality of service it will be like smooth and with no problem. Security and privacy in spectrum share. Secure spectrum sharing protocols such as spectrum encryption and authentication mechanisms protect against unauthorized access and malicious attacks. Privacy preserving spectrum sensing techniques like differential privacy and secure aggregation safeguard users' sensitive information during spectrum sharing. Spectrum access control mechanisms limit access to specific spectrum bands based on user credentials and authorization policies to prevent authorized usage. Let us know what is resource management in cognitive networks. Dynamic resource allocation algorithms optimize spectrum, power, and bandwidth allocation based on network demand and channel conditions. Spectrum aggregation techniques combine fragmented spectrum bands to create wider bandwidth channel for high data rate applications. Energy efficient resource management strategies minimize power consumption and enhance network sustainability in cognitive heterogeneous networks. So dynamic resource allocation has predictor application models and allocator and resource, and it gives out the monitor, shows in the monitor. What is spectrum sharing use cases? Dynamic spectrum sharing enables efficient utilization of underutilized frequency bands such as TV's white spaces for broadband connectivity. Spectrum trading platforms facilitate spectrum leasing and sharing agreements among networks operators to address temporary capacity demands. Mission critical applications like public safety and communications and industrial IoT benefit from reliable and secure spectrum sharing mechanisms in 5G cognitive networks. Cognitive radio testbeds. The cognitive radio testbeds such as Orbit and GNU Radio provides a platform for evaluating spectrum sharing algorithms and protocols in real-world scenarios. SDR, that is a software-defined radio platforms, enable flexible and programmable spectrum access, facilitating rapid prototyping and testing of cognitive networking concepts. Testbed deployments help validate spectrum sharing performance metrics such as latency and interference mitigation under controlled experimental conditions. So this is about future trends in spectrum sharing. Spectrum sharing technologies such as blockchain based spectrum and trading and AI spectrum management will enhance spectrum efficiency and flexibility in future networks. Integration of 5G network with satellite communication systems will enable seamless spectrum sharing across terrestrial and space-based platforms. And evolution towards 6G networks will further advance cognitive spectrum sharing capabilities and enables autonomous and self-optimizing network operations. So this is the case study about dynamic spectrum sharing. It provides dynamic spectrum sharing optimizes spectrum efficiency and network performance by dynamically adapting to changing radio environment conditions. And it is required for maintaining connectivity and QoS requirements. This is about dynamic spectrum sharing. And the end of my presentation, sir. Let's conclude the presentation with the conclusion slide. Advanced spectrum sharing techniques are essential for maximizing spectrum efficiency and meeting the diverse requirements of 5G cognitive heterogeneous networks. So the future research and development efforts will focus on enhancing spectrum sharing mechanisms, addressing security and privacy concerns, and optimizing spectrum utilization in evolving wireless communication system. That's the end of my presentation, sir. Thank you so much for giving me this wonderful and great opportunity. I hope you like my presentation, sir, on this particular topic. I hope positive feedback from you, sir. Thank you so much once again.